In this lesson, we'll solve an optimization problem about maximizing the area of a rectangular pen. We'll find the optimal dimensions to maximize this area. First, let's understand the problem we're trying to solve. Our goal is to find the width and length of a rectangular pen that will maximize its area. We have 60 meters of fencing available, but we only need to fence 3 sides because one side will be against a barn wall. Here's a sketch of our rectangular pen. The top side is against the barn wall, so we don't need fencing there. We need to fence the left side, bottom side, and right side. Now, let's set up the equations that describe this problem. Our constraint is that the total fencing used on 3 sides equals 60 meters. That's 2 times the width plus the length. The area we want to maximize is width times length. We can solve our constraint equation for y to get y equals 60 minus 2x. Substituting this into our area formula, we get a of x equals x times 60 minus 2x, which simplifies to 60x minus 2x squared. Now let's find the maximum area by analyzing this function. First, we notice that our area function is a downward opening parabola because the coefficient of x squared is negative. Here's the graph of our area function. It's a parabola that opens downward with a maximum at x equals 15, giving a maximum area of 450 square meters. Let's verify this maximum using calculus by taking the derivative. The derivative of our area function is 60 minus 4x. To find critical points, we set the derivative equal to 0. That gives us 60 minus 4x equals 0. Solving for x, we get x equals 15. The second derivative is negative 4, which is less than 0, confirming this is indeed a maximum. Now let's find the corresponding length and verify our solution. We know that y equals 60 minus 2x. Substituting x equals 15, we get y equals 30 meters. First, let's check that our solution uses exactly 60 meters of fencing. 2 times 15 plus 30 equals 60 meters, so that checks out. The area with these dimensions is 15 times 30, which equals 450 square meters. Here's our optimal rectangular pen. The width is 15 meters, the length is 30 meters, and the area is 450 square meters. So our final answer is, the optimal width or depth from the barn is 15 meters. The optimal length along the barn is 30 meters. These dimensions give us a maximum possible area of 450 square meters.